Good morning, everybody. I am Dr. M. Parameswari, Associate Professor of Computer Science, Erode Arts and Science College. My broad area is software engineering. Now, I am going to discuss with you introduction of software engineering. Introduction to software engineering. Computer software continues to be the single most important technology on the world stage. 60 years ago, no one could have predicted that software would become an indispensable technology for business, science, and engineering. No one could predict that millions of computer programs would have to be corrected, adapted, and enhanced as time passed. The burden of performing these maintenance activities would absorb more people and more resources than all work applied to the criterion of new software. Evolving role of software. Software is a product, transforms information, produces, manages, acquires, modifies, displays, or transmits information, delivers computing potential of hardware and networks. Software is a vehicle for delivering a product, controls other programs, that is operating system. Affects communications, that is networking software. Helps build other software, that is software tools and environments. What is software? Software can be defined as instruction executed provide desired features, functions, and performance. Data structure to adequately manipulate operation. Documents operation and use of the program. Software products may be developed for a particular customer or may be developed for a general market. Software products may be generic, developed to be sold to a range of different customers. Example, PC software such as Excel or Word. Bespoke, that is custom, developed for a single customer according to their specification. Hardware versus software. In hardware, manufactured. In software, developed or engineered. In hardware, wear out. In software, deteriorate. In hardware, built using components. In software, custom built. In hardware, relatively simple. In software, complex. Manufacturing versus development. Once a hardware product has been manufactured, it is difficult or impossible to modify. In contrast, software products are routinely modified and upgraded. In hardware, hiring more people allows you to accomplish more work, but the same does not necessarily hold true in software engineering. Unlike hardware, software costs are concentrated in design rather than production. This is failure curve for hardware. This is failure curve for software. When a hardware component wears out, it is replaced by a spare part. There are no software spare parts. Every software failure indicates an error in design or in the process through which design was translated into machine executable code. Therefore, software maintenance involves considerably more complexity. Component based versus custom built. Hardware products typically employ many standardized design components. Most software continues to be custom built. The software industry does seem to be moving, that is slowly, toward component based construction. Software characteristics, differences with hardware. Software is developed or engineered. It is not manufactured. Software does not wear out, but it does deteriorate. Software continues to be custom built as industry is moving toward component based construction. Software application domains. First one, system software. That is, system software is a collection of programs written to service other programs. It is characterized by heavy interaction with computer hardware, heavy usage by multiple users, concurrent operation that requires scheduling, resource sharing, and sophisticated process management, complex data structures, and multiple external interfaces. Example, compilers, operating system, drivers, etc. Next application is application software. Application software consists of standard-alone programs that solve a specific business need. Application software is used to control the business function in real time. Next application is engineering and scientific software, characterized by number crunching algorithms. Applications range from astronomy to volcanology, from automotive stress analysis to space shuttle orbital dynamics, and from molecular biology to automated manufacturing. Example, computer aided design, that is CAD, system simulation, etc. Next application is embedded software. It resides in read-only memory and is used to control products and systems. Embedded software can perform limited and esoteric functions. Example, keypad control for a microwave oven. Next application is product line software, designed to provide a specific capability for use by many different customers. Product line software can focus on a limited and esoteric marketplace. Example, word processing, spreadsheets, CG, multimedia, etc. Next application is web and mobile applications. Web and mobile applications can be little more than a set of linked hypertext files. It is evolving into sophisticated computing environments that not only provide standalone features, functions, but also integrated with corporate database and business applications. Next application is artificial intelligence software. AI software makes use of non-numerical algorithms to solve complex problems that are not amenable to computation or straightforward analysis. Example, robotics, expert system, game playing, etc. Definition. The IEEE definition for software engineering. Software engineering, number one, the application of a systematic, disciplined, quantitative approach to the development, operation, and maintenance of software. That is the application of engineering to software. Number two, the study of approaches as one. Software engineering layers. Software engineering is a layered technology. Any engineering approach, including software engineering, must rest on an organizational commitment to quality. The bedrock that supports software engineering is a quality focus. The foundation for software engineering is the process layer. Process defines a framework that must be established for effective delivery of software engineering technology. The software process forms the basis for management control of software projects and establishes the context in which technical methods are applied. Work products, that is, models, documents, data, reports, forms, etc., that are produced. Milestones. Milestones are established, quality is ensured, and change is properly managed. Software engineering methods provide the technical how-tos for building software. Methods encompass a broad array of tasks that include communication, requirements analysis, design modeling, program construction, testing, and support. Software engineering methods rely on a set of basic principles that govern each area of the technology and include modeling activities and other descriptive techniques. Software engineering tools provide automated or semi-automated support for the process and the methods. When tools are integrated so that information created by one tool can be used by another, a system for the support of software development called computer aided software engineering. It is established. The software process. A process is a collection of activities, actions, and tasks that are performed when some work product is to be created. An activity strives to achieve a broad objective, example, communication with the stakeholders, and is applied regardless of the application domain, size of the project, complexity of the effort, or degree of rigor with which software engineering is to be applied. An action, that is, example, architectural design, encompasses a set of tasks that produce a major work product. Example, an architectural model. A task focuses on a small but well-defined objective. Example, conducting a unit test that produces a tangible outcome. In the context of software engineering, a process is not a rigid prescription for how to build computer software. Rather, it is an adaptable approach that enables the people doing the work, that is, software team, to pick and choose the appropriate set of work actions and tasks. The intent is always to deliver software in a timely manner and with sufficient quality to satisfy those who have sponsored its creation and those who will use it. The process framework. A process framework establishes the foundation for a complete software engineering process by identifying a small number of framework activities that are applicable to all software projects regardless of their size or complexity. In addition, the process framework encompasses a set of umbrella activities that are applicable across the entire software process. A generic process framework for software engineering encompasses 5 activities. Communication. Before any technical work can commence, it is critically important to communicate and collaborate with the customer and other stakeholders. The intent is to understand stakeholders' objectives for the project and to gather requirements that help define software features and functions. Next, planning. Software project plan defines the software engineering work by describing the technical tasks to be conducted, the risks that are likely, the resources that will be required, the work products to be produced, and a work schedule. Next, modeling. Create a sketch of the thing so that you will understand the big picture, what it will look like architecturally, how the constituent part fit together, and many other characteristics. Next one, construction. What you design must be built. The activity combines code generation, either manual or automated, and the testing that is required to uncover errors in the code. Next one, deployment. The software as a complete entity or as a partially completed increment is delivered to the customer who evaluates the delivered product and provides feedback based on to the evaluation. Summary. Software is the key element in the evolution of software-based systems and products and one of the most important technologies on the world stage. The nature of software is changing: web, mobile, cloud, etc. Software engineering encompasses process, methods, and tools that enable complex computer-based systems to be built in a timely manner with quality. The software process incorporates 5 framework activities: communication, planning, modeling, construction, and deployment that are applicable to all software projects. Software engineering practice is a problem solving activity that follows a set of core principles. Thank you.